Hi all. So this is another problem in which we have to find the power delivered by this 4 ampere current source. Okay, so again we are not given any method with which we have to find the solution of this problem. So we have to select ourselves which is the convenient method for us to find the required quantities. So again we have basically discussed two methods for solving the unknown quantities in a circuit, and these methods are the mesh current method and node voltage method. Okay, so we have to see that which of these two methods is convenient or feasible for this circuit to find the power delivered by the source of 4 ampere current source. Okay, so now here first of all let us see the feasibility of the node voltage method. If we select the node voltage method, what is the first step? The first step is to identify all the nodes or in a circuit. So here we have basically 1, 2, 3 and 4 nodes. Okay, so if we select this one as our reference node, so then we will have to find the voltages at all of these 3 nodes. Okay, we have to find the voltages at these 3 nodes, and then we will get a system of linear equations containing 3 unknown and 3 equation will be there. So finding the solution of a 3 by 3 equation is somehow tricky, and it basically needs us to use Cramer's rule or Gauss elimination method. Okay, these are the methods which we have to use, or any other methods which you find feasible for you to find the solution. Okay, in all the other circuits in previous videos, I have used an online resource for me which is called Wolfram Alpha for finding out the solution. Similarly, you can also use the MATLAB or Python. There are many packages in the Python, and one of them is the SciPy or NumPy. You can use these methods. You can use these packages for finding the inverse of any equation, or to find out the solution of any system of linear equations. Okay, so this is the system of linear equation. So this is the overall concept behind the solution of any number of equations which I have been using in my videos. So this method, the node voltage method, is not convenient for this circuit. So let me look at the other method which is called the mesh current method. Okay, if I am using the mesh current method, so I have to basically deploy 3 currents here. The first one is here, let me call it I1, the second one is I2, and the third one here is the I3. Okay, so if I want to find out the solution of this circuit, I can see here that the sole current here in this branch is basically the I3, and I can clearly see that the value of the current at this branch is 4 amperes. So already I have found out the value of I3. So how many loops are then remaining? There are basically 2 loops which are remaining, which are I1 loop of I1 and a loop of I2, or I can call them the meshes of I1 and I2. So I have to solve them, and then I will get equations containing 2 unknowns, and 2 equations will be there, and solving the 2 by 2 equation instead of this 3 the equation containing the 3 unknowns is easier for us. Okay, so that's why I will be using here the method which is called the mesh current method. Okay, so let me remove all these things and use the mesh current method here. Okay, so in these circuits you have to look for the convenient method whichever is feasible for you. Okay, so for this circuit the known quantities here are basically I have found out that the value of I3 is 4 amperes. Similarly, the value of Ix, what is the value of Ix here? The value of Ix here is basically the I1 minus I3, or putting this value of I3 here, I will get I1 minus 4. Okay, so this is again my question solution here. And similarly, the value of 30 Ix, which is a source, dependent source, current controlled dependent voltage source here, so the value of it will be 30 I1 minus 4. So these are my equations which are known here. So now after it I have to consider the mesh number 1, and in mesh number 1 I have to apply the KVL. Okay, so when I will apply KVL, I can see here that the 128 voltage source is the voltage rise. Similarly, V4 plus V6 plus V2, these three are the voltages. V4, V6, V2 are the passive elements across which the voltage is going to drop. Okay, so the voltage rise is equal to the voltage drop is the KVL equation. So writing them now here, I will get 128 is equal to V4, and V4 is basically 4 multiplied by I1 minus I3. Similarly, 6 will be V6 is equal to 6 multiplied by the I1 minus I2, and the third one is 2 here. So the only current which is flowing through this 2 ohm resistor is the I1 current, so here it will become 2 multiplied by I1. Okay, so now again simplifying it, I will get 4 I1 minus 4 I3 plus 6 I1 minus 6 I2 plus 2 I1. This is equal to the 128. Okay, so now adding the relevant terms, 4 I1 plus 6 I1 plus 12 I1, this is the 12 I1. Similarly, it will be minus 6 I2 and minus 4 I3, this is equal to the 128. Okay, the value of I3 is already given, which is 4. So now writing the value of I3, I will get 12 I1 minus 6 I2 minus 4 16 equal to 128. Okay, so now it will become 12 I1 minus 6 I2, adding 16 in the both at both sides of this equation, I will get this 16 will be cancelled out with the other 16, and the 128 will be added with the 16, and I will get here 144. Okay, or similarly taking 6 common here, I will get 2 I1 minus I2 equal to 144 divided by 6. Okay, let me move down. So here the equation will become, here the equation will become 2 I1 minus I2 is equal to the 144 divided by 6, and that is equal to the 24. Okay, so that is equal to the 24, and let me call it equation number 1. So this is my equation number 1. Similarly, in order to find the in order to consider the mesh number 2 here, let me write all the equations of mesh 2 here. Again applying KVL in mesh number 2, I will get here V6 plus V5 plus V3 and here this is again the voltage drop, so this will be 30 ix is equal to 0. Okay, so V6 is this one, V5 is this one, and V, okay, so and this one is the 30 ix current dependent current controlled dependent voltage source. So now let me write their values. V6 is equal to 6 multiplied by I2 minus I1 plus 5 multiplied by the only current here is the I2, and V3 is 3 multiplied by I2 minus I3 plus 30 ix equal to 0. Okay, now simplifying it, I will get 6I2 minus 6I1 plus 5I2 plus 3I2 minus 3I3 plus, and writing the value of Ix, which is basically the I1 minus 4. So I will write here 30 I1 minus 4, this is equal to 0. So adding the relevant terms here, again minus 6.1 will be here, and the 6I2 3I2, okay, this one will be here. So I will get the plus 9I2 plus 9I2 here, and here and plus 9I2, okay, 6 plus I2, and here 5I2 is again here, okay, excuse me for this, and minus 3I3 plus 30 I1 and minus 3 into this is 120 equal to 0. Okay, so let me simplify them again. So I will get here, these two terms will again be added, and I will get the 24 I1 plus 14 I2 and minus 3 multiplied by I3. What is the value of I3? That is 4. So minus it 4 multiplied by 3 will be equal to the 12 minus 120. Okay, this is the 30 I this, okay, so that is equal to 0. So let me simplify them again. I will get 24 I1 plus 14 I2 equal to the plus 132. Okay, so that is the equation here. So let me take 2 common here. From here to dividing both sides by 2, I will get here 12 I1 plus 7 I2 equal to the 66. Okay, so this is my equation number 2. So now I have 2 equations and 2 unknowns. What are the unknowns? I1 and I2 are the unknowns. So now here multiplying equation 1 by 7, okay, and then adding them together. So 7 multiplied by equation 1 plus adding with 2, what I will get here? I will get here 14 I1 minus 7 I2 is equal to the 168, because 7 multiplied by 24, and similarly now adding it with the 12 I1 plus 7 I2 is equal to 66. Okay, so now after 8 adding them together, these two will cancel out. Here I will get 26 I1 equal to 168 plus 66 is 234. Okay, and now here I will get I1 equal to the 234 divided by 26 is 9 amps. So this is the required quantity of I1. Okay, I have done it using the black color, so please this is the overall equation and not just for the mesh one, so please remind it to yourself, because I have used different colors for both the meshes, but black is the general color here, the convention I have been using. Okay, so now I have mistakenly used blue here, but the solution is just like this one. Okay, so now similarly, now putting this value into the equation number 1, I will get 2 multiplied by the I1. So the I1 is 9 minus I2 is equal to the 24. Okay, so now here 18 minus I2 is equal to the 24, or the value of I2 is equal to the minus 6 amps. So this is the value of I2. So these are my equations, I1 and I2. And what should I have to find out? I have to find out the power which is provided by this source. Okay, so the power which is provided by the 4 ampere source is basically the P4 is equal to the I multiplied by voltage across the V4. So the voltage across this one is this, so that voltage is basically the V3 plus V4. Okay, and the polarity is this one, and this polarity is valid for the I3 current. So the value of P4 is basically I multiplied by what is the value of V4. The value of V4 is V3 plus V4, let me call it V4 prime. So the value here is V4 prime. So now putting values here, I multiplied by what is the value of V3. The value of V3 is the I3 minus I2, or let me simplify it. Okay, let me find it very simply, because it is making some confusion here. So the value of V4 here, let me call it equation A. Okay, so the value of V4 is basically equal to the V3 plus V4 prime. Okay, as from this circuit, because now using the KVL, okay, this is by KVL in this loop. So the value of V4, all the voltage which is here, this is V4, and this is equal to the sum of these two voltages. So now the value of V3 is 3 multiplied by the current through it, and the current through is I3 minus I2. And similarly, the value of V4 prime is equal to the 4 multiplied by the value of I3 minus the value of I1. So I know the value of all these quantities. So 3 multiplied by what is the value of I3, that is 4 minus what is the value of the I2, that is 6. So 4 plus 6 is this. Similarly, the value of this 4 multiplied by what is the value of 4, and the value of I1 is basically the 9. Okay, so 3 into 10, this is 10, and this is 30, plus what is the value of this? This is basically minus 5, and minus 5 multiplied by 4 is minus 20. Okay, so I will get here V4 here is 30 minus 3, this is 10 volts. Okay, so this is V4, and let me call it equation B. So now put B in A. Okay, I will get here P4 equal to the I multiplied by V4, which is 10, and what is the value of I, that is 4. So 4 multiplied by 10, and ultimately I will get 40 watts. Okay, so this is the value of the power which is delivered by the 4 amperes source. So that is the answer of this question. 40 watts is the answer of this question, which is the power which is provided by the 4 ampere source. So that's it for this question. Basically we have to find the convenient method for us to solve our circuit here, and we find it by analyzing both of the method we studied, that the mesh current method is the convenient one here. So I hope you will use and deploy the same methodology as we deployed here for the